My name's Tim Robinson. I'm a solution architect. I've been working for Amazon for about 1.5 years now. I'm here today to talk to you about containers, about the use of our technology, our ecosystem, the integration of that with OpenShift technology, and maybe a few other bits and pieces architecturally as we go along. I'm going to be around afterwards, so if anyone's got any questions about today's session, please come and speak to me. I'll be over at the booth in the other room. So, let's get going. How many people are from a technical background here? Wow, everyone. And how many people have used AWS before? Oh, man. So I can't lie to you or say anything. Okay, so we'll start high level. So in terms of architectural priorities, the last couple of years we've seen quite a big shift inside Amazon and I guess across the industry. So traditional architectures, when I came out as a graduate, 99% of them were based on what we call a scale-up model. So in a traditional architecture, we would build up in single silos. We'd add more and more resources as time went on. We capacity plan in terms of data centers, all that sort of stuff. At the time, dealing with customers in that way was pretty effective for us. As time's gone on, we really work towards this scale-out model. So we move away from this pet-style architecture where when an application breaks, when it falls over, we tend to it, we try and heal it back, bring it back to health again. We now move towards what we call a scale-out model. So in terms of a scale-out model, we treat our architecture like cattle. We align them with numbers rather than names, and we really work off the process of templating our architecture in order to scale it out for a mass market. Scale-out architecture is efficient, it's able to deal with a larger audience, especially from a web perspective. And now with public cloud being so prevalent in today's market, what we're finding is scale-out architecture is growing more and more within our environments. So in terms of industry shifts, what sort of stuff do we look at in the majority of architectures? Well, when we grade architecture, when we look at it in the field, there's really a number of different priorities that we work towards. So the first is availability. So in terms of an architecture, how do you achieve that uptime? In terms of elasticity, how does your architecture cope with changes in demand? Can your architecture cope with a sudden influx of customers? Perhaps if you're a web-based company, you've got maybe a Black Friday event or something similar to that. Can your architecture scale out to meet those demands? And more importantly, can it shrink back afterwards? And in terms of agility, changing requirements, is your architecture able to implement new features, fixes, so on and so forth? All the addition of CI/CD pipelines and all that sort of thing come under really the agility banner. So really what we'll do is we'll go through those individual industry categories and we'll talk a little bit from an Amazon perspective about how we play into those individual areas. And then we'll kind of sum up and talk a little bit about OpenShift. So in terms of availability, what do we actually categorize or how do we denote what availability really means? So in IT terms, high availability refers to a system or component that is continuously operational for a desirably long length of time. So we really measure against 100% operational or never failing. And this really gives us a bit of an issue in terms of architecture because we're dealing with machines at the end of the day, with servers. We talk a lot about serverless. serverless is not serverless. Serverless eventually does run on a server somewhere. So from an AWS perspective, how do we achieve that high uptime for our customers? How do we make sure it's uniform, a uniform experience across countries, across continents? A lot of our secret sauce is in how we construct our data center technology, how we combine it together, how we culminate into regions, and so on and so forth. So in AWS, we have a term called an availability zone. So an availability zone is our foundation building block with which we create a region. So we're kind of unique in the market in that when we build out an availability zone, more often than not, we build out across multiple data centers. The use of multiple data centers means that we draw from redundant power, cooling, etc. But in terms of our choice of data centers, we ensure that they're geographically fairly close together. And what this means is that in terms of latency between them, we're able to achieve an incredibly low latency, almost to the same degree as if you were in the same room. So our data centers that we use to combine together to create an AZ are less than a quarter of a millisecond apart in terms of latency. So we can combine multiples. We have up to 6 data centers held within a single availability zone. And again, this varies across the world. Historically, the US regions have larger availability zones. But again, increasingly, we're adding to these year after year. One of the other important aspects is that a data center isn't present in more than one availability zone. So what this means is we don't continuously reuse DC structures in multiple AZs. And this means that ultimately they're highly fault tolerant across the region. So in terms of regions, we then take these availability zone structures, we combine them together, and those availability zone structures, when combined, form what we call a region. So a region is essentially a mesh of availability zones combined together. We combine them together with redundant paths between them. And we also have private links between our regions. So that means that once you hit the AWS infrastructure, when you move between regions, if you create a replication structure between Sydney and Singapore, for example, that replication structure flows across our backbone, so it goes across private fiber. So again, because that fiber's private, it means that we continuously monitor, and again, we can control latency, traffic, etc. In terms of availability zone latency, we're talking around about 2 milliseconds as a broad stroke. And most of our availability zones are less than 1. Again, it does vary region to region. A region like Singapore, where the geographical landmass is smaller, will obviously have a slightly lower latency time. So this is really what it looks like in terms of HA. So again, you can see our individual regions built out here. Each one made of multiple availability zones connected via a mesh. Each availability zone made up of multiple data centers, all working on that low latency combination. So in terms of native services that we use for availability, we've got a huge amount available. We have auto scaling, we have CloudWatch, we have load balancing. We're now up to 3 separate load balancers within our infrastructure. And all of these combine together in order to give that high uptime experience for our customers. So let's move on to elasticity now. So what does it actually mean in terms of a definition? So elasticity is the degree to which a system is able to adapt to workload changes. So in terms of being able to provision and deprovision resources, hopefully in a autonomous manner, such that at each point in time, those resources are available to our customers. Again, this plays into themes of efficiency. Do you really want to capacity plan for the worst possible scenario? Do you really want a web service that is oversubscribed 15, 20 times? Probably not, right? You probably want to take that money and invest it somewhere else. So the ability for us to work through concepts of elasticity mean that our architectures are as efficient as possible. So again, what this means from a load balancing perspective is behind our load balancers, we place auto-scaling structures. These auto-scaling structures give us the capability of being able to automatically provision when there's high load. Again, we create triggers within our environments based on metrics that you define yourself. So perhaps from a CPU or a memory perspective, you want to set a high watermark, and after that trigger occurs, you can automatically provision another instance. And again, equally, when that customer demand goes down, the deprovisioning going the opposite way. We offer other services as well, like CloudFront, which is a great example. So CloudFront is our ability to take predominantly web-based traffic, video content, all of that sort of thing, and cache that locally within region. So outside of our regions, which contain compute, storage, etc., we also have what we call edge locations, and those edge locations allow us to create cache content locally. So what this means is if you build and deploy your application in Singapore, you can run that and access that web-based infrastructure from anywhere in the world, and providing you've got that service, you access it in the same manner with the same latency. So it gives you a nice evenness over that customer experience. So the third pillar we're going to talk about is agility. So agility is really the ability to quickly and smoothly adapt, integrate newer technologies, your ability as a company to be able to disrupt, to expand, to utilize new technology, and to be more effective as a business. So when Amazon first started, we were, and always have been, predominantly a web-based business. Our move towards continuous integration across our environment has really revolutionized how we work, how we operate, and how we create our business. So within Amazon today, on our retail platform, we're performing releases across our environment roughly every 6.6 seconds. This enables us to tailor our experience very, very quickly according to customer demand, according to the time of year, according to buying patterns that we're seeing. And all of this is possible through our use and our harnessing of this mechanism of agility. So how do we really do that internally? Well, a lot of that is the combination of the use of containers and continuous integration pipelines. So we'll probably talk about that a little bit now. So really in terms of the classic problem that developers and IT operations both need each other, but unfortunately it's often a very unhappy marriage. They both have very different objectives. They both have very different KPIs. And again, they're both required within a company in order to produce that end product. So from a containers perspective, what do containers actually mean? Well, it kind of depends who you ask. So in terms of infrastructure people, containers represent lighter, more malleable virtual machines. It means across environments, these concepts become totally portable. So the ability to take a on-premise Docker container and move it up into a cloud-based infrastructure is now possible. So from an infrastructure perspective, portability, efficiency, all of those themes. From an application perspective, perhaps the most important factor is the ability to package all of your dependencies together. So containers give you this ability to create that continuous user experience, whatever the underlying platform is. Containers also harness this ability to distill down all of your infrastructure, your application, into code. And this again plays into CI/CD pipelines. So the ability to integrate and deploy to any environment in seconds with the use of CI/CD pipelines is really integral to what containers represent. So what does this really mean to you? Well, we've talked about the ability to produce small incremental changes that allow you to deploy more efficiently, with a lot more confidence over an extended period of time. We give you the ability to run the same code on your laptop that you do up on the cloud, and really to streamline your development and your deployment process. In terms of hybrid technology, again, what we saw 2 or 3 years ago was customers really dipping their toe into the water of public cloud. I would say today, the majority of customers are actively pursuing public cloud, either as a dev test initiative in sandbox environments, but needless to say, hybrid environments are very much a key point to the majority of businesses that we see out there today. So containers give portability to provide that high availability and elasticity. It gives you the faster iteration of application and services, but more importantly, through the use of integrated security, which we see as a priority inside Amazon. We can harness that integrated security and again, give you that repeatable experience a lot more efficiently and a lot more securely. So in terms of components, we've really got 4 individual components here that would go into our container-style platform. We'll need some form of host, perhaps with an enterprise-grade operating system. We'll need some form of storage, so persistent storage for stateful containerized applications. Again, the creation of state within containers is still quite a contentious issue, but the movement from traditional into containers is not always a smooth journey, so the use of persistence is definitely a valuable term in the or valuable use in short term. From management, the ability to manage containers and infrastructure at scale, and again, a platform to automate, to build, and eventually to distribute. So again, this very much a repeated slide, I would say, today, but very much how we see containers playing into the whole DevOps lifecycle. So the ability to take code from a source repository, to pass it in through a CI/CD engine of your choice, again to have the target being some form of containerized platform, and then to take that containerized platform and inject into either a physical environment, on-premise, virtual, on-premise, it really doesn't matter, be it cloud or from a public point of view or a private. So really what this culminates to is, how does this play from an OpenShift perspective? Well, as far as the OpenShift platform is concerned, there's been quite a lot of deep dive sessions, I think, today on OpenShift, so I'm not going to go too deep into it, but at a high level, container application platform is based on a mix of technologies internally, which include Docker and Kubernetes for the building and distribution of containers which run at scale. From a container platform, again, we've got this multi-layered approach with our self-service catalog at the top, containing automation, and again the lifecycle management and so on and so forth, all this integrated together to produce that single developer experience. Perhaps the most important factor when you're looking at the next steps from a business development point of view is being able to define your infrastructure as code. Defining infrastructure as code means you really free yourself from the physical constraints of an environment. It means that your business, your operations become instantly portable. From an AWS perspective, OpenShift is totally integrated from an Amazon ecosystem. What this means is we're able to launch the product, we're able to run that product within our cloud, we're able to script that deployment, so you don't need to spend a huge amount of time and go on a load of courses to understand all of our individual tool sets. We provide it for you as an individual template, and we'll come on to how you can utilize that template in a minute. Perhaps what's more of interest to some of you existing OpenShift customers is the use of the AWS Service Broker. So what the Service Broker really represents is an ability for you to consume natively our cloud-based services from your OpenShift environment, be it either on the cloud already or on-premise. So via a broker, we can access these tools natively. So we give you a choice of a number of different tools. Each one of those tools you can consume through that same familiar single pane of glass. And again, combine your existing infrastructure and then play into our cloud services as you see fit. So perhaps a great example would be something like a Redshift environment. So where you had a OpenShift deployment, perhaps on-premise, you wanted to access a data warehouse, perhaps run some analytics or something like that. Through the use of the connector, you can reach out to our native services, and through something like Redshift, you can start and mine that data. We give you access to DynamoDB, which is our NoSQL offering. Again, no need to capacity plan at all. All of that is available for you on demand. And again, various other services, including S3 and RDS. So we have a full list of those available. It even spans into technologies like Lex for artificial intelligence and chatbot manipulation. So in terms of how we deploy, how do we differentiate? So from an AWS perspective, if you want to build OpenShift, this is really the templated best practice deployment. So again, you can see those availability zones that I talked about at the start of the session as those three verticals in the background. And again, over those, we layer a number of EC2 instances, and then those EC2 instances are combined with automation via Lambda and a number of load balancers, again, to give you that templated deployment. We offer you the ability to deploy on a number of different instance sizes according to your needs. But the important thing is we give you this template as a zero-cost artifact to yourselves. And we offer you the template with a single push deployment. So a single button will execute this to give you that OpenShift environment for you to either evaluate or to run in production. So what does this mean to you? What it means is the integration into AWS services, either natively, so from an OpenShift perspective, you can perform your deployment quite happily within our cloud natively. Through the use of the connector, you can consume our services from an on-prem perspective. We give you access to our global footprint, so over 18 regions now across the world. And again, from a security perspective, integration of security techniques at every layer within our environment. And finally, from a partner ecosystem, we have a number of common partners between Red Hat and AWS. So again, if you're looking to perform some form of OpenShift migration, or you need skills that are rich from both an AWS and a Red Hat perspective, please reach out to either Red Hat or ourselves. We can put you in touch with an appropriate consultant or technology partner suitable to your needs. So I really wanted to finish with this. So this is a use case quite close to home, so it's quite appropriate. So Macquarie Bank have recently worked on an OpenShift deployment which runs on AWS. I think we got some Macquarie people here today. So this really, I won't go into how big Macquarie Bank is. I think you're probably all aware, predominantly Australians. But the migration of 60 businesses and over 150 services really is quite a staggering achievement for a business of that size. So in terms of improvement in developer productivity, the ability to deploy code, update fixes, etc., 50% improvement in developer productivity. So again, a really good story there. So that kind of concludes where we are from a technology perspective. So again, if you want to talk about how to get access to the Quick Start template that we talked about, you want to talk about the connector, or how to use the Cloud Accelerate program for existing Red Hat customers, please do come and speak to me at the booth. I'm going to be hanging around after this session. So thank you very much for your time, and hope to see you soon.